Once upon a time. Well, not really. This happens quite a bit. There are these things that cause the changes in the blood pressure. Changes in the blood pressure are detected by the stretch receptors in large arteries above the heart. These are called baroreceptors. Well, now you're probably wondering, what is a baroreceptor? They are sensors located in the blood vessels of the human body. They can detect the pressure of blood through them and can send messages to the central nervous system to increase or decrease the total peripheral resistance and cardiac output. The total peripheral resistance is the overall resistance of the blood flow through the systemic blood flow, and the cardiac output is defined by the volume of blood pumped per minute by each ventricle of the heart. They act immediately as part of a negative feedback system called the baroreflex. As soon as there is a change from the usual blood pressure, it returns the pressure to a normal level. The baroreceptor reflex is a reflex arc consisting of baroreceptors that supply information about the blood pressure to areas in the brainstem which control the sympathetic and the parasympathetic output to the heart and vessels to return the pressure back to normal. The sympathetic tone is a continuous stimulation of smooth muscles in the walls of the blood vessels. It also stimulates the body's fight or flight response. The parasympathetic tone originates in the brainstem and in the lower part of the spinal cord. It opposes the sympathetic nervous system, and it does this by slowing down the heartbeat and also by dilating the blood vessels. Well, now you're probably wondering, how does this work? These baroreceptors are located in the carotid sinus and in the aortic sinus. The carotid sinus baroreceptors are innervated by the glossopharyngeal nerve and the vagus nerve. When it is stretched by increased blood pressure, it inhibits the cardioacceleratory center and it stimulates the cardioinhibitory center. The cardioacceleratory center is responsible for increasing cardiac output, and the cardioinhibitory center is responsible for slowing down the action of the heart. Then the glossopharyngeal nerve and the vagus nerve synapses in the vasomotor center of the medulla oblongata of the brainstem. The vasomotor center is located in the medulla oblongata of the brainstem, and in the vasomotor center, it regulates the blood pressure, breathing, and the heart rate. After the baroreceptors are stimulated, the parasympathetic tone is increased towards the heart, and as a result, the heart rate decreases. The stimulation of the baroreceptor also decreases the sympathetic tone towards the heart, and it decreases the heart rate and stroke volume. The sympathetic tone is also decreased in the blood vessels, which causes vasodilation in the blood vessels. Vasodilation is a widening of blood vessels, which decreases the blood pressure. Now that the heart rate is decreased and the stroke volume is decreased, and also because of vasodilation, the blood pressure returns to normal. Thank you very much.